Have you ever wondered how we can see the Earth's surface with incredible detail, even through thick clouds, dense fog, or the darkest night? Have you ever wondered how we can see the Earth's surface with incredible detail, even through thick clouds, dense fog, or the darkest night? The secret isn't a superpower. It's a revolutionary technology called Synthetic Aperture Radar, or SAR for short. Today, we're going to pull back the curtain on this amazing imaging tool, explore how it works, where we use it, and even how it played a crucial role in modern history. So what exactly is SAR? Let's break it down. First, you have radar, which stands for radio detection and ranging. A standard radar sends out a radio wave, which bounces off an object. By measuring the time it takes for the signal to come back, you can determine the distance to that object. It's like shouting in a canyon and timing the echo. But this gives you a pretty basic, low-resolution picture. This is where synthetic aperture comes in. Imagine trying to take a detailed photo with a tiny camera lens. It would be blurry. To get a sharp image, you need a large lens, or in radar terms, a large antenna. But strapping a massive, kilometer-long antenna to a plane or satellite isn't exactly practical, right? SAR is the genius solution to this problem. Instead of using one giant physical antenna, it uses a small, moving antenna. As the platform, like a satellite or an airplane, flies along a path, it continuously sends out radar pulses and collects the returning echoes from the ground. It then cleverly combines all these return signals collected over a distance. Using some seriously smart signal processing, the computer stitches all this data together as if it were collected by a single, gigantic synthetic antenna. This aperture isn't real. It's created virtually, synthetically. The result? An incredibly high-resolution image that would otherwise be impossible to get. One of the biggest advantages of SAR is that it's an active sensor. Unlike a regular camera that needs light from the sun, SAR provides its own illumination in the form of radio waves. This means it can see day or night. And because radio waves can penetrate clouds, fog, smoke, and even rain, SAR can capture clear images of the ground when optical cameras are completely blind. It gives us an all-weather, 24/7 view of our planet. So, where can we install these amazing systems? The versatility of SAR means it can be mounted on a variety of platforms. The most common are satellites orbiting our planet. Satellites like Sentinel-1 from the European Space Agency or the RadarSat constellation from Canada constantly circle the globe, providing a steady stream of SAR data for scientists and governments. Airplanes are another popular platform. Airborne SAR systems offer more flexibility. You can fly them on specific routes, at different altitudes, and revisit an area of interest more frequently than a satellite might allow. Drones, or unmanned aerial vehicles, UAVs, are also increasingly being equipped with smaller, lightweight SAR systems, making this technology even more accessible for targeted surveillance and mapping. There are even ground-based SAR systems used for monitoring things like the stability of dams, buildings, or landslides. Now for the really exciting part. What do we use SAR for? The applications are incredibly diverse and impact our daily lives in ways you might not expect. In environmental monitoring, SAR is a game changer. Scientists use it to track deforestation in the Amazon, monitor the melting of polar ice caps and glaciers, and measure the extent of floods. After a flood, optical images might just show a big muddy mess. But SAR can differentiate between land and water with precision, even under cloud cover, helping emergency responders know exactly where to go. It's also a vital tool in agriculture. By analyzing SAR images, farmers can monitor crop growth, assess soil moisture levels, and even identify areas affected by pests or disease. This helps optimize irrigation, improve crop yields, and promote sustainable farming practices. Think of it as a high-tech health checkup for entire fields, from space. Geology and disaster management rely heavily on SAR. It can detect tiny, centimeter-level ground movements. This is crucial for predicting volcanic eruptions by spotting ground swelling, monitoring land subsidence in cities, and assessing landslide risks. After an earthquake, SAR can quickly create damage proxy maps by comparing before and after images, showing responders which buildings and infrastructure have likely been damaged. Of course, SAR also has significant military and intelligence applications. Its ability to see through clouds and at night makes it perfect for surveillance and reconnaissance. It can be used to monitor troop movements, identify military hardware, and track changes at strategic sites, all without being affected by weather conditions that would ground other forms of aerial observation. This brings us to a fascinating piece of history. The use of SAR in a major conflict was famously demonstrated during Operation Desert Storm in the early 1990s. The weather over the region was often poor, with frequent cloud cover and smoke from oil well fires obscuring the battlefield from traditional optical satellites and spy planes. The United States military deployed aircraft equipped with advanced SAR systems, like the JSTARS platform. These systems were able to peer through the smoke and clouds, providing clear images of the ground. This gave coalition forces an unprecedented, near real-time view of Iraqi military positions, vehicle movements, and supply lines. They could track tank formations and mobile missile launchers, even when they were hidden under camouflage or moving at night. This intelligence was a massive strategic advantage, allowing for more precise targeting and a better understanding of the battlefield dynamics. It marked a turning point, showcasing how powerful all-weather imaging could be in modern warfare. From helping farmers grow our food to guiding rescuers after a disaster, from monitoring the health of our planet to shaping the outcomes of historical events, synthetic aperture radar is a silent, unseen hero of modern technology. It's the eye in the sky that never blinks, constantly gathering data that helps us understand and protect our world in astonishing detail. It's a perfect example of how human ingenuity can overcome physical limitations to see the world in a whole new light, or in this case, a whole new frequency. If you found this fascinating, make sure to hit that like button and subscribe for more explorations into the amazing technology that shapes our world.